This is Kelly Hill, Technology Reporter for RCR Wireless News. I'm here today with Kurt Schmidick, who is VP of Marketing for LitePoint. Welcome, Kurt.
Thank you, Kelly.
Great, and we're going to be talking about NFC testing today, and I'm wondering if we can start off with just a little bit of an introduction to LitePoint and what you folks do.
Sure, yeah. The LitePoint's been around since 2000. We're primarily focused on high-volume production test of wireless devices. The wireless functionality you find in smartphones and in tablets, Wi-Fi routers, the embedded modules that go often in some of these small portable devices, and also in IoT, or Internet of Things. We target about 30 different wireless standards with our solutions, so giving complete test capabilities to manufacturers to test a plethora of different wireless standards, including short-range systems like Bluetooth or Wi-Fi, Zigbee, DEC, to wide area systems like GSM, wideband CDMA, and LTE. We have customers throughout the world that use our products to test literally billions and billions of devices. We have a strong reputation in connectivity testing, things like Wi-Fi. But 2014 was good to us in terms of establishing ourselves in the cellular domain as well. And now we're, I guess, privileged to be serving the majority of the top smartphone manufacturers throughout the world with solutions to test their LTE and wideband CDMA solutions. Then in 2014, we introduced our NFC tester. This was the world's first production-level NFC tester. Of course, the reason we're here today is to talk to you.
Yes, definitely. So I see you have some equipment there behind you. Maybe we can start out with a little bit of, what is NFC as a technology? How does it differ from some of the other wireless technologies that are typically found in wireless devices?
Sure, yeah. Well, NFC stands for Near Field Communications, and as the name implies, it's a very short-range communication system designed not to transfer lots of data, but to transfer small chunks of data to enable other things to happen. Those other things can be things like mobile transactions or pairing of devices. But the concept is more about short range to enhance security, have an inherent security strategy by making the range typically about 4 centimeters. And then the data transfer is not critical. We're talking about hundreds of kilobits per second relative to standards like Wi-Fi, which are approaching gigabit per second rates. So it's a very targeted technology with specific applications. It's not really competing with a Bluetooth or a Wi-Fi. It's designed for very specific applications and typically very short-range transmission to allow some other event to happen. Again, a mobile transaction or perhaps a pairing of one device to another without having the user to have to do a whole lot of work to enable that transaction to happen.
Okay. Now we're expecting to see a lot of growth actually in NFC. We had Apple Pay emerge in this past year. I'm starting to hear rumors that Samsung may be coming out with its own version of a payment system. We're starting to see some of these things materialize in the market, and I think I've seen some predictions that we're expected to see growth in that area, as well as proliferation of the types of devices that have NFC capabilities. So I'm just kind of wondering, from your perspective, what are some of the trends that you see in applications for NFC capabilities and devices?
Sure. Yeah. Well, I think the application that gets all the press today, of course, is payment. We're seeing an uptick in the amount of mobile transactions that happen that are enabled by NFC. And of course, Apple's caught the press a lot, but Google was out there a few years ago with Google Wallet. There's payment systems throughout the world using it, to be honest. Not typically smartphone-based, but based on more simple cards that allow access to subways, access to buildings, access to sport venues. So the technology has been with us for a while, but really, at least in the United States, when we really hear about a lot is Apple Pay, Google Wallet, and some of the competitive technologies, like you mentioned, or competitive solutions like the rumored Samsung Pay, which, of course, is getting the press. But NFC, again, goes farther. There's a lot of interesting applications it can do beyond the payment side of things. Great example that have been around for a couple of years, the ability to pair your smartphone to, say, a wireless speaker. Typically, entering Bluetooth access codes is a little cumbersome for most consumers. But if you could take your phone and simply wave it over the speaker, and they're paired automatically, that's a very useful application. Same thing is true with pairing, say, a Bluetooth headset to a phone. Bring them two together, you're paired. Same with the mouse to a laptop. If the laptop had Bluetooth, NFC in it, simply moving the mouse, it's also NFC enabled over the computer to link them together. So NFC has kind of a broad-ranging set of applications in technology. We're even seeing it applied for advertising, kind of smart advertising, where NFC tags are embedded in a poster, a smart poster. And a consumer that sees that poster in a store or a bus stop or whatever can move his phone up to the poster and gather more information. So it's going to have a very broad-ranging effect, a broad-ranging set of applications that it can enable. But it's really about simplifying things, making either transaction friction lower or simplifying the whole consumer experience when it comes to pairing devices which are typically either cumbersome or maybe beyond the reach of comprehension of some consumers. Why do I have to enter 6 digits into my phone when I'm pairing it with my car? It's complicated. So NFC can really simplify things dramatically.
Okay. So let's talk a little bit about NFC testing. Can you talk about some of the important pieces there? What are some of the RF parameters or physical parameters that are involved in testing to make sure that this functions the way it needs to?
Sure. Yeah. So, like any wireless technology, NFC should be tested in production. There can be variations in components. There can be variations in the coil, which you can kind of think of as an antenna. And of course, there can be variations in the integrated circuits to implement the NFC functionality. So there are literally probably 100 things that can go wrong with NFC in a production environment. Same thing would be true for LTE, wideband CDMA, any of the wireless technologies. But we've kind of narrowed it down to just a few fundamental things to minimize test time. As manufacturers put products in the factory, they want to find ways to get good quality of test, but of course minimize the test time. Because time is money, as they say. So we've pared it down to just about 6 basic items that really will give you good confidence that your NFC circuitry is working well. The first one is resonant frequency. So that's the operating frequency at which NFC functions. And you want to make sure that the target and the initiator, kind of the 2 sides of the equation, whether it's your phone and the reader, or your phone and the door opener at the factory, or at your company, they need to be broadcasting on the same frequency. So measuring the resonant frequency of the system is key. And that resonant frequency is influenced dramatically by the coil. That coil is simply a mechanical structure, and that can change. So verifying that the resonant frequency is correct is a key thing. Field strength is the next thing. You need to be sure that your product is actually radiating enough power to energize a passive device. I mentioned the smart poster, for example. I would move my phone next to this poster. The poster doesn't have batteries. It's simply a passive device. So there needs to be enough energy radiated by my NFC circuitry in my phone to energize the poster. It's a small amount of power, but it's important that field strength, that power, is generated the right level, and of course the right resonant frequency we mentioned before. Then there's receiver sensitivity. How sensitive is the receiver? If I'm energized or if there's a transaction of data, I got to be sure that my NFC circuit is sensitive enough to receive that data accurately. So we need to check that. Kind of hand in hand with receiver sensitivity is the quality of the transmission, signal quality. How accurate is the transmission that my device emits? Is the what's called load modulation amplitude, is it within specification? You need to verify that. Also, transaction time is a key thing in NFC. Consumers are impatient. You want to be sure that the product, your device, when it's passed over a reader at a store at Macy's or wherever, functions properly and functions quickly. So what's called response time of the target, and that's measured by something called frame delay. That's a key thing to verify in your product. And finally, you want to do an overall functional test. Does the whole thing work? Can I actually move data back and forth? Is there a full transaction? That's a basic functional test of both the initiator and the target. So those are the 6 key things. But it gets a little more complicated in that most smart devices operate in multiple modes. One is as a target, which means they're being spoken to. One as an initiator, which means they initiate the transaction. And the third is called peer-to-peer. And that's the idea of 2 devices coming together and kind of talking together as equals. So if you're going to do these tests, like I mentioned, all those 6 tests, you want to do them in all different modes, and you want to cover all 3 different NFC standards, NFC A, NFC B, and NFC F. So it's a fairly complicated matrix. It's 6 multiplied by 3 multiplied by 3 again.
Just a quick question to clarify. So you talk about something like a smart poster where there's a passive, passive on the poster side and then active on the device side. Does that also, is it different when you're talking about, say a terminal reader for mobile payments? Is that active on both sides of the transaction, or is it a different type of interaction there?
Yeah, it's typically the reader is the active part, called the initiator in some cases, or the poller. So again, there's 3 different standards. Each have their own terminology, but let's just keep it simple. We'll call it initiator and target. So typically, if you're at a store making a transaction, the device on the counter is the initiator. It's generating a field to energize the target. Now, you can get credit cards that are basically passive devices, and they get energized by the initiator. They're called targets. But your phone can also act as a target, basically passive. Even though it is an active device in terms of having a battery, in this particular payment mode, it's acting as a target. So flexibility in the NFC circuitry is critical, so you can act in every different way and interact properly with the device you're communicating with.
Okay, great. So let's talk a little bit. What kind of companies are conducting NFC testing? You mentioned, you guys are looking at large-scale production. Are we talking mostly OEMs? Are operators interested in having test capabilities as well? What other, who is your target audience in terms of NFC testing?
Yeah. So, typically our key customers are the ones that are producing the smart devices in volume. So, of course, we target all the smartphone companies, people that make smartphones, people that make tablets, and people that make peripheral devices that are NFC enabled. But there's a bigger ecosystem, as you pointed out, and that is financial institutions. It is companies that make readers. So every part of the ecosystem does some level of test. And typically it's, if you think about a bank or you think about a company making, say, the readers, they think more about conformance testing. Does my product meet the standards? And there's a set of tests that are done early in the development phase of the product before it's launched to market to ensure that it meets the standards. And we do work with them as well, with these kind of companies, to look for correlation between our tester and what they use for conformance. But I think what often gets forgotten, and this has been, I think, a symptom of NFC for the past few years, or an issue with NFC for the past few years, is that there's a belief that once it's put into the phone, it's going to behave properly. It's low frequency, it's a simple communication link, it's only a few centimeters. What could go wrong? But there are many things, as I just talked about, that can go wrong. Variations in components, variations in the coil that's in the device, and even simple things like solder mask on a printed circuit board can have an impact on performance of NFC. So it's been our goal to kind of educate manufacturers that even though this is a relatively inexpensive, seemingly simple solution, if we take samples of products that are on the market, we see wide variation in performance. So there's a high likelihood, and this is backed up by actually data in the market, of failed interactions between devices and readers, where there is fluctuations in component tolerances in the manufacturing cycle, and you get inconsistent performance between a reader and a target, or initiator and a target. So, we've seen the data, and I think as companies get more serious about, especially commercial transactions, that need for production level NFC testing grows. So, frankly, even being here today is a bit about education. It's in our best interest to see our customers excel and deliver good quality products, whether it's for NFC or for Wi-Fi or for cellular. So, part of it's the education process. That it's again a seemingly simple technology, but it's not really the case when you actually look at it in depth. So, yes, we target the OEMs, but it's certainly, we talk to every phase of the ecosystem, whether it's the major financial institutions, whether it's the companies that enable, the credit card companies that enable these kind of transactions, the manufacturers of readers, the manufacturers of smart devices. And at this point, there are some key guys that are testing very, very well, but there's still, I'd say, they're a minority relative to the total NFC ecosystem in terms of smart devices. More testing is definitely needed. Okay, well, let's talk a little bit about that.
how is NFC tested? You ran through some of the important pieces. Can you give us a sense of how it's alike or different from other wireless technologies that are also embedded in these devices, and that people may be more familiar with testing? Obviously, we've had the cellular connectivity for a while. Over time we've added things like Wi-Fi, like Bluetooth. I think NFC is maybe a more recent comer in terms of some of the mobile devices. You mentioned, it's been used in other areas, identification cards and other things. So can you talk a little bit about, similarities and differences in approaching this type of testing?
Right, sure. So, if you compare this to Wi-Fi testing or cellular testing, what you often see in a production line is what's called conducted test. So as the printed circuit board moves on the manufacturing line, there's a variety of tests that are done on the more conventional wireless technologies like Wi-Fi, Bluetooth, LTE, etc. And that can be conducted effectively with literally attaching a cable to connectors in the printed circuit board and running through a battery of tests. And you get a very good indication of performance. In fact, in some standards, the only way to actually do calibration and verification testing is with a conducted test. But there's always that last phase. You attach an antenna, and you want to be sure it works. But typically, the antenna impact on the Wi-Fi or Bluetooth or cellular functionality is less than you'd see in NFC. NFC you really have to consider as the entire system. There's the IC functionality, which is critical. There's the coil, or you can think of it as the antenna, which is also very key. And there's a set of matching components that go between the coil and the IC. And even small deviations in the performance of any of those has an impact on things like resonant frequency and field strength. So the big difference I see between NFC and other more mainstream wireless technologies is that you really need to test the product as a system with the coil in place, the matching components, and the IC. So there can be sub-steps in the process where you test them individually. The really important thing with NFC is to test it as a system, because until you do that, you don't really know how it's going to behave in the real world.
Okay. How sensitive is it? I'm wondering about things like, in a wireless device, typically you're dealing with, vibration. You might be dealing with, temperature fluctuations. You have, maybe 2, 3, 4 other wireless technologies in there as well, depending on the device. Mm-hmm. Can you talk a little bit about, this is a short-range technology, and I'm curious as to, how robust is it? What are some of the considerations and concerns in making sure that it works as part of a mobile device?
Sure. Yeah. Well, it's a learning curve, I think, for many companies. We see interesting implementation methods where the coils are typically, they're sizable. They can be anywhere from a few inches in diameter to maybe, a few centimeters. Of course, the smaller the coil, you're going to get into some of these issues you mentioned about sensitivity, range. But we see interesting design methods, let's say, that are often revolving around industrial design of a product. We see NFC coils embedded on top of batteries. We see them embedded behind aluminum casings. And these things all have an impact, especially metal, on this inductive technology that NFC is. It can have a dramatic impact on performance, on its range, on the quality of the signal. So, yeah, there definitely is sensitivity. And one of the big sensitive issues in NFC, the fact that it's an inductive technology, which means you bring two devices together and they impart energy on each other through an inductive process. So things can interfere, whether it's metal on a table, whether it's metal in the phone, metal in the reader. All these things can have an impact on performance of the system. The fact that it is very short range, there's less likelihood in the real world of interference from other radiators, but it's possible. But typically what we're seeing is when the NFC circuitry is designed on the phone, on the tablet, the considerations of desensing or detuning the coil is not always thought about. And that's where you see kind of funny variations in performance. So I think it's a matter of as manufacturers become more familiar with the technology, understand how best to place it within a device, as performance improves on ICs, you can make them more tunable in terms of how they behave over different operating scenarios, we'll see improvements. But for now, you know, it really is a sensitive technology, sensitive in terms of the components used, and of course, sensitive in terms of how it's implemented inside the device. So that's really, it's critical if you're gonna go through the bother of doing conformance testing. You want to make sure that every device that comes off the production line is consistent in terms of its performance unit to unit, and that's how you ensure the user experience.
Mm-hmm. I'm curious. You know, I was just looking. I have a Samsung S5 phone, and you know, it's a fairly long device. And I'm just thinking about NFC in terms of tablets. You know, do you find that often companies have to put some kind of external indicator as to where the NFC coil setup is, so that people can place the device appropriately?
Yeah, we do see that. Was thinking about Sony products, the Xperia line. They literally have a little marker on the back of the phone to tell you where the NFC coil is centered. You know, I think companies, they want to think about the use case model. You know, maybe Apple's a good example. The fact that you put your finger over the fingerprint sensor kind of dictates how you would hold the phone over the reader. So, you know, they were thinking a lot about use case models. But I think in other implementations, Samsung or Sony or HTC or the rest, sometimes we do see a need to put a marker on there. And that kind of relates also to the quality of the connection. Is the product behaving, you know, in the ideal scenario, or at least as expected in terms of, you know, the right kind of range, the right kind of sensitivity, the right kind of field strength? Ideally, you wouldn't have to actually mark it, but we do see situations where you do see phones that actually have kind of a, here's the bullseye, here's the optimal place to put it. And consumers learn, you know, by use. But the first couple experiences are critical. If it doesn't work well the first time, it may detract them from using it again. You know, just think about some recent market data we've seen. Consumers that are using NFC now for mobile transactions, they tend to become more loyal to the retailers that actually have deployed it. So, you know, a combination of good user experience, you know, from a simplified transaction perspective, and then reliability of the product. Tie that together with merchandisers or merchants that have actually embraced the technology. You know, all kind of comes together to brand loyalty, or to retailer loyalty, and also brand loyalty for the product, for the device itself. So, you know, a combination of kind of thinking through the use scenarios and then delivering the best possible technical solution from a usability perspective is critical to keep consumer confidence high and grow the adoption of NFC for mobile payments and other applications.
Now, one last thing, you do have some equipment there with you. I'm wondering if you can kind of tell us what you got there and how it's used.
I'd be happy to. So this is the IQ NFC. You can see it's a relatively small device. This is about half the size of some of our connectivity testers used for Wi-Fi. It's called a 1U form factor. It's designed really for production. It's a very rugged design. There's an incredible amount of abuse that happens in a factory environment. Operators not particularly familiar with the equipment. A lot of abuse that can happen to cables. So you need to build products that are rugged and built to stand up to these kind of more harsh environments. And that's what the IQ NFC represents. We've also built something here which we call a universal test head. I mentioned there's 3 different NFC standards and a variety of different operating modes. So ideally what you'd have is a solution that can cover all standards with a single insertion. You know, it's not good to have to do insertions over and over and over again in a production line. Ideally, the operator can place the device one time, run through a battery of tests. That's what the IQ NFC does. It actually moves through all 3 standards, all 3 operating modes in about 5 seconds. So you can have very, very complete coverage with a single insertion, thanks to this universal test head and the kind of adaptability that's built into the IQ NFC test solution.
Okay. Great. Well, Kurt, thank you so much for your time today. I've been talking with Kurt Schmidick, who is VP of Marketing for LitePoint, and we've been discussing NFC testing. Thank you so much for the time today.
Thank you, Kelly. I appreciate it.